In this numerical of projectile, two balls are projected from the same point in directions at 30 degree and 60 degree to the horizontal, as shown over here, right? And both of these projectiles attain the same height. Then we need to find the ratio of their initial velocities. When the projectiles are projected, they will go and follow the trajectory as I am showing it over here, and they will attain their respective maximum heights that I am showing, right? The maximum height attained by both the projectiles are same. This is given into the question. Let's say LM and PQ are the maximum heights which are attained by both the projectiles. So as per the data given into the question, LM is equal to PQ, right? Let's say both the projectiles are A and B. So I am writing over here the projectile A, which is projected at angle of 30 degree, right? So the angle of projection of projectile A is 30 degree. Similarly, for the second projectile B, we will write the same thing, that is projectile B is projected at angle of 60 degree. This is the data which is given into the numerical. Now this is 30 and this is 60. One angle is 30, another is 60. 30 degree for A projectile and 60 degree for B projectile. Now as per the question, the maximum height attained by the projectile A will be equal to the maximum height attained by projectile B, right? So I am writing it over here. Students, you know the maximum height. What is the formula of maximum height of any projectile whose initial velocity is u, projected at angle theta? It's u²sin² theta by 2g, 2 into a small g, right? So if the initial velocity of both the projectiles are UA and UB, okay, let's say UA is the initial velocity of first projectile, that is projectile A, and UB as the initial velocity of projectile B, right? Then as per the formula of maximum height, u² sin² theta by 2z will be constant for both the projectiles. So both are same. So I am writing it over here, ua² sin² theta A by 2z is equal to ub² sin² theta B by 2z, where ua is the velocity of projectile A, this I am writing, and ub is the initial velocity of projection of projectile B, right? Now theta A and theta B, what are that? Theta A is the angle of projection of projectile A, whose value is known to us, that is 30 degree, and the angle of projection of projectile B, that is theta B, that value is known to us, given into the question as 60 degree. So put up the value over here, simply put up the value, 2g will be cancelled out, and ua² by ub² can be written as sin² theta B by sin² theta A, right? So theta B and theta A is known to us, that is 60 degree and 30 degree respectively. So put up the value of 60 degree and 30 degree in place of theta B and theta A. So we get into the numerator of RHS sin² 60 degree divided by sin² 30 degree, and the value of sin 60 is √3 by 2. So just put up the value over here. So √3 by 2 whole square divided by 1 by 2 whole square, because sin 30 is 1 by 2. So this will give you 3 by 4 into 4 by 1. 4 will be cancelled out. Here 4 will be cancelled out, and we are left with 3 by 1. Just to take the square root of both sides of the equation, since ua by ub whole square is equal to 3 by 1, applying a square root on both sides of the equation in this way, what will come out into the LHS? We will have UA by UB, that is initial velocity of projectile A by initial velocity of projectile B. The ratio of both projectiles initial velocity is there with us into the LHS, and root 3 by 1 is the ratio. So we have calculated the ratio of initial velocity of both the projectiles which attain the same height after projecting at 30 degree and 60 degree respectively will be is equal to root 3 is to 1. So just like and subscribe, students. Bye bye.